So far, we've only been thinking about interactions between individuals in terms of two species that either have positive effects or negative effects on one another. Of course, in a real community, a whole suite of species that are living together in the same place, you're going to have more than two species. And different species can interact with more than one partner. So for example, here we've got the dragonfly. When it's young, it can be eaten by a fish. When it's an adult, it can kill pollinators. The pollinator in turn is interacting with the dragonfly and with a mutualist, this plant that it pollinates. When you get these chains of interactions, a change in the relationship at any point can have sort of chain reaction effects on everybody else that it's connected to. So for example, if you get a larger number of fish in a particular stream, they can reduce the number of dragonflies. So then the dragonflies aren't present to reduce the number of pollinators go up, and in turn that allows these plants to have more offspring. So it's not just that the fish interacts with the dragonfly. The fish interacts indirectly with every species that the dragonfly interacts with, and indirectly with every one of those other species' interactions. So you very quickly, when you've got multiple species interacting in a real community, you very quickly form an interaction web, which can be extremely complicated. This has important real-world implications. One of the troubling things about ecology is it can be very difficult to predict what's going to happen when two species interact. Let me give you a classic example of this. This is an organism known as the cane toad. This lovely, charming creature is called the cane toad because it was introduced to Puerto Rico quite some time ago when an organism called the cane grub was attacking the sugarcane plantations there. The cane toad devoured the sugar grub in huge numbers and prevented the collapse of the sugar industry in Puerto Rico. Because it was so successful, when this grub down here started appearing in the sugarcane fields of Australia, the cane toad was again imported in order to take care of this problem. What nobody realized, though, was that what would happen is that these beetles down here, these are beetle larvae, instead of being eaten by the cane toad, they would just climb to the top of the sugar canes. Toads are terrible climbers. And so, in fact, this toad, which had been marvelous at keeping down the numbers of the sugarcane grub, barely affected the gray-backed beetle grub at all. So let me say that one more time. Frequently, we can't predict what's going to happen when two species interact. Now let's think about any species in its actual setting, which can be a setting that is extremely diverse and contains lots and lots of different interactions. If we can't predict one interaction in this whole interaction web, it means we may also have trouble predicting what's going to happen as a result of that interaction, and what's going to happen as a result of the results of that interaction. In other words, one change to an ecosystem frequently leads to these sort of chain reaction effects that nobody predicted. Are these necessarily bad? No, but they really can be. An example occurred I think it's right about early in the 1900s, off the Pacific coast. These little organisms up here, these furry little critters, are called sea otters. These are the organisms that have charmed the pants off the internet by floating around and holding hands. Unfortunately for the sea otter, it has a very thick, very luxurious fur coat. And in the late 1800s, people coveted this fur for items of clothing. As a result, the sea otter was hunted almost to extinction. The assumption of people at the time was that, this wasn't going to change things very much in the kelp forest ecosystem where the sea otter lived. The problem is that, as it turned out, sea otters love to feed on these little spiny animals, which are sea urchins. And sea urchins, in turn, love to feed on kelp. Kelp, in turn, provides a hiding place where all sorts of fish and other species like to lay their eggs and hide and thrive. So when the sea otters were removed, instead of having these lovely, beautiful, species-rich kelp forests, what you got was this. This is called an urchin barrens. What's happened here is that there are no predators to control the sea urchins. They have exploded in numbers. They have eaten all of the kelp, and all of the organisms that depended on that kelp forest for survival have left. This is something that we really would not have predicted. People who were studying the kelp forests in the 1800s would not necessarily have guessed that this sort of thing would occur if you remove the sea otters. And we're still in that same fix today when it comes to most ecosystems. We really can't predict what happens if we nudge or change one species that's connected to all of these other species. One rule that we've basically learned is almost always true is when you start making major changes to an ecosystem, it's going to have some kind of unexpected side effect. And that's something you really need to be aware of whenever you're thinking about changing anything in a natural ecosystem of any kind.